go, good job. Arc length is radius times radians. All right, I'm 57 years old. Every single time somebody says arc length to me, I think radius times radians. All right, so what is that? How does that work in this problem? Well, let's see. It says, find the radius. The central angle is 1.5 radians and the arc length is 12. Formula, arc length equals radius times radians. So 12 equals R times 1.5. So R equals 12 divided by 1.5. Right. Now, we don't have a calculator for this, so you might want to think of that as 12 divided by 3/2, which is 12 times 2/3, which would be 8. So the radius is 8 centimeters. The unit on the radius will match the unit on the arc length. Now, let's skip down to the bottom quiz. These quizzes are exactly the same, just given in different periods. So let's skip down to the bottom one and do that. Number 2 says find the arc length. Given theta is pi over 7 and the radius is 10 feet. So again, the formula says arc length equals radius times radians. So the arc length, I don't know what it is, but I know my radius is 10 and my radian measure is pi over 7. So 10 pi over 7 feet would be the answer to the question. Okay, all you whiners and complainers, that is not hard. Right? Okay, back up to the top quiz. Number 2. Change 4 pi over 9 into degrees. Now, 4 pi over 9 is a radian measure. We need to change it into degrees. There are a couple of ways we can do that. Anybody remember? So I can set up my proportion. Pi is 180. That is like 1. Pi radians is 180 degrees, just like 12 inches is 1 foot. These two are the same. So then I can say 4 pi over 9 must be what? That proportion will always work. Now, there is a little bit of a shortcut for this problem, but if that makes sense to you, then that's the way you're going to do the problem. It will never fail you, ever. It will work every time. So if we cross multiply, pi x equals 180 times 4 pi over 9. Remember, there's no calculator here. 9 goes into 180. How many times? 20. And 20 times 4 is 80. So pi x equals 80 pi. If we divide by pi, then x equals 80 degrees. Now, you can shortcut that if you want to. You had 4 pi over 9 radians. Now, what do we know about pi radians? Pi radians is the same as 180 degrees. So that is like 180 degrees. What is 1/9 of 180? 20 times 4 is 80. So you can do the problem that way too if you want to. All right, so let's go down. Let's look at number 3. Number 3 at the bottom. I'm going down to the quiz at the bottom now. Number 3 is exactly the same problem, except it's 5 pi over 9. So we could set up our proportion, or we could shortcut that and say, well, wait a minute. Pi is 180 divided by 9, 20 times 5, 100. So this is the same as 100 degrees. Or if that doesn't make sense to you, you can just set up this proportion right here, cross multiply and solve, and you'll get 100 degrees. All right, back up to the top one. Change 200 degrees into radians. Same problem, just backwards. So what's our proportion? Pi over 180 is x over 200. Pi radians is 180 degrees. X radians is 200 degrees. So, multiplying, I get 200 pi over 180. That is what? 10 pi over 9? So the answer is 10 pi over 9. Down at the bottom. What?
Would the pi and the 180 not cancel out?
No. No, they don't. They're different units. This is pi radians, that's 180 degrees. So they're equivalent, but they don't cancel each other. They're not the same thing. 310 degrees. I'm looking at the bottom quiz now, and I'm doing 310 degrees. So what's the strategy? Pi is to 180 as something is to 310. So x equals 310 pi over 180. Those will cancel, and that's it. So it looks like 31 pi over 18 would be the answer. All right, we did all that last time we were together. We're not going to go back over it again. That's easy stuff. And oh, by the way, just because we don't have math class does not mean you shouldn't be getting it out and looking it over. All right, on the back side. Now we've got our calculators, getting our calculators out. Before we get our calculators out, we don't really need a calculator for number 6. I know we talked about these two things, the number 6 on both quizzes, the top and the bottom. Who remembers the 6 at the top? Who remembers what we mean by standard position? When we say we're going to draw an angle in standard position. Who remembers what that means? Did we talk about that? We didn't talk about standard position? Okay, good. We'll do it right now. When we draw an angle in standard position, it means that you start on the positive x-axis. So every angle we draw in this class, in any math class that you ever take any time in your life, every angle you draw in standard position will start right here. And if it's positive, it's going to go up. And if it's negative, it's going to go down. So I am drawing a negative 100 degree angle. So I'm going to start right here because it's where I always start. It's a negative angle, so I'm going to go down. How far am I going to go if I'm going 100 degrees? To about here, right? Because we know that a full revolution is 360. So every quadrant is worth how many? 90. So if I'm going 100, I have to go through one quadrant and just a little bit into another one. Right? So there would be your standard position angle. Now, every angle we draw, so if you're on the phone talking to some kid in Germany, and he's saying, you know, I got this 170 degree angle. Your angle you draw is going to be exactly the same as his. You're going to draw 170 degrees exactly the same as any person anywhere. The only exception to that is if the angle is dealing with navigation. So in other words, if it's directional. If we're saying, here's my ship, I'm going to sail on a course of 80 degrees or something. If the angle is navigational, directional, then the rules are different. We use a compass, and everybody's seen a compass before, so you know this is the way a compass is set up. And due north is 0. East is 90, south is 180, and west is 270. So if you're dealing with navigational angles, for example, 6 at the bottom, draw a course of 211 degrees. You're going to start your measurement due north, that's 0, and you're going to go 211 degrees clockwise. So this would be a course of 211 degrees in a navigation problem. Okay? So if someone said, draw a course of 82 degrees, a course of 82 degrees starts here, so that would look like that. That would be 82 degrees. Remember, every quadrant is 90. So you have to figure out how many quadrants you need to go through, or in this case, I don't even get a full quadrant. So that would be a course of 82. All right, so there's 2 ways that we draw angles. If the problem has any mention of, here's a plane on a course, here's a ship sailing, here's a car driving, then you're going to want to go with your compass. If you are finding the sine of 200 degrees and you need to draw 200 degrees, then you draw it in standard position. Okay? So an angle of 200 degrees in standard position. Start here. Positive 200 degrees, I would be going up. 200 degrees would take me all the way around to here. So that would be a standard position angle of 200 degrees. Now, you might be thinking to yourself, Ms. Ford, what's the big deal? Well, the big deal is that your trig functions, sine, cosine, tangent, secant, cosecant, cotangent, are all positive or negative in different places. And if you don't have your angle drawn in the right quadrant, you won't know whether things are positive or negative. It is important that you get your angle drawn in the right spot. Okay? All right, well, speaking of angles, now we're going to go to our calculator. Did we talk about any of this? I don't think we talked about this. So, when you draw an angle, or when you talk about an angle, we are used to just talking about it in terms of degrees. But did you know that degrees can be broken down into smaller pieces, much like the hours on a clock? An hour, think old-fashioned clock, an hour can be split up into 60 minutes. And each of those minutes can be split up into 60 seconds. Well, the same is true of a degree. A degree can be split up, 1 degree can be split up into 60 pieces called minutes, and each of those minutes can be split up into 60 pieces called seconds. Now, why is that, do you think? Well, I want you to think back, or just think about how big our Earth is. So think about how big the Earth is. It's a big thing, right? So when we talk about, like if I drew a circle on the board and I said draw a degree, it would be really small, right? Because I need to get 360 of those around there. But if you're talking about the size of the Earth, a degree, because the Earth is so big, a degree would be a pretty big chunk, right? So navigators said, wait, I can't just say 80 degrees, that's too big of a space. I have to narrow it down if I'm a search and rescue plane or something. I need to narrow it down. So I'll say 80 degrees, 10 minutes, and 14 seconds. Well, that really narrows down that angle. Luckily, your calculator has a capability to handle that. So let's look at the top quiz, number 4. Says change 114 degrees, 18 minutes, and 13 seconds into decimal degrees. Now, what we mean by decimal degrees is 114.72 degrees. That's called decimal degrees. So we want to know if we have 114 degrees, this is not going to be the right number. If we say 114 degrees, 18 minutes and 13 seconds, what is that in terms of a single decimal? So on your calculator, if you just type in 114, and then you have what's called your angle menu. It's second apps. It says angle right above that key. See it? Right here, look where I'm pointing. Right here. All right, press that. And as soon as you press that, what's the very first thing at the top? A degree mark. Press enter. And now it will throw that symbol up for you. So then I'm going to press 18. Just literally type 18. And then I'm going to go back into that second angle menu, and notice what's the second one underneath the degree mark. It's your minute mark. This is your minute mark, so press that. So now the calculator should say 114 degrees, 18 minutes, right? So now I'll press 13. All right, now here's where things get crazy. All right, this is going to blow your mind. I don't know why this is. But the second mark is not in the angle menu. The second mark is above the plus sign on your calculator. It's a green, so you're going to press alpha plus, and that pulls in your second mark. See it? Above your plus sign, it's in green. So you, to get the green things, you do alpha. So alpha plus, and there it is. Now press enter. And it says 114.3036 degrees. So there's the decimal degree for 114 degrees, 18 minutes, 13 seconds. All right, let's try number 5 at the bottom. Same problem. We're going to put in 77 degrees. Everybody remember how to get degrees? 18 minutes. They remember how to get minutes. Excuse me. And 32. We're at number 5 on the bottom. We're practicing another getting decimal degrees. So 32 seconds. Did you get 77.3089 if we rounded off to 4 decimal places? All right. So everybody knows how, if an angle is given to you in degrees, minutes, and seconds, you know how to input that into your calculator. Yeah. Okay. So then the last question is number 5 at the top. You're given 44.55. So in other words, you're given decimal degrees, and we're going to change that back into degrees, minutes, and seconds. All right, so here's what we do. We type 44.55. Go into your angle menu, so that's second angle, and notice option 4. What do you think DMS stands for? Degrees, minutes, seconds. Press enter a couple times, and it says 44 degrees, 33 minutes, and 0 seconds. If you go into the angle menu, go down to DMS, press it a couple times, comes out. All right, let's do problem 4 at the bottom. 89.57. We're going to change that into degrees, minutes, seconds. What'd you get? 89 degrees, 34 minutes, 12 seconds. So now, if we have degrees, minutes, seconds, we know how to put it in. If we need degrees, minutes, seconds, we know how to get it out. Right? What?
Is there ever we have to draw a course with a negative number or negative degree?
No. Negative, I mean, you could do it, but we just don't do it because we use the compass points, and those are the angles on the compass. So, okay, yeah, I'll of course ask you to do that. All right, now, whiners and complainers. When you walk in this room tomorrow, you are going to get this is 2 half-sheet quizzes, you got that, right? You're gonna get a half-sheet quiz tomorrow where the front is no calculator and the back is with calculator. So have your calculator with you and be ready to press the buttons that we pressed today. Got it? Now, in addition to that, tomorrow, when you walk in the room, because I'm taking pity on your poor souls, you are going to have the memorization quiz that you were supposed to have had the last time we had class.
We didn't have.
We had tests and then we didn't.
Oh, it was supposed to be today then, because it was supposed to be the day after you took your test, so is this the day after? Okay, well, I'm not giving it to you today. I'm still taking pity on your souls. You need to have memorized the stuff on the back of that gold sheet. Kids, we cannot proceed without it. Now, the graphs, I'm not quizzing you over the graphs tomorrow. I'm quizzing you over the special right triangles, like the 30, 60, 90, 45, 45 right triangles, and the definitions of the trigonometric functions.
30, 60, 90, 45, 90.
Yes.
Where is that? That's on here too. That's on
Yes, it's on the sheet.
I could have said it's clear.
Now,
What is a cotangent?
a cotangent is a reciprocal of a tangent. So if tangent, TOA, opposite over adjacent, then the cotangent would be adjacent over opposite. It would behoove you to memorize the reciprocal relationships. Tan and cotan are reciprocals. So Mrs. Ford does not have memorized the definitions of the cotangent. I have memorized the definitions of the tangent, and I know the tangent is the reciprocal of the cotangent. So if tangent is opposite over adjacent, the cotangent is adjacent over opposite. I will never get them confused because that's how I have learned them, as reciprocal relationships. The reciprocal of the cosecant is the sine. The sine and the cosecant are reciprocals. So I don't have the cosecant memorized. I have the sine memorized. Sine is opposite over hypotenuse. Sine is opposite over hypotenuse. It is y over r. Therefore, if someone quizzes me over the cosecant, all I need to do is remember it's the reciprocal of the sine. So since the sine is y over r, the cosecant is going to be r over y. Since the sine is opposite over hypotenuse, the cosecant is going to be hypotenuse over opposite. I don't get those confused because I have memorized them as reciprocals. And I would suggest you do the same. You have SOHCAHTOA already memorized. So you already know some of the definitions for sine, cosine, and tangent. The reciprocals then come automatically. Alright? Now, we cannot progress if you do not have those memorized. I am going to today talk about stuff that requires you to know that. You must have those foundational pieces memorized, okay? I am sorry that you didn't believe me when I told you the last time we had class, not test day, but the time before, that those had to be memorized. I'm sorry you didn't believe me when I handed out the gold sheet 4 weeks ago and said those have to be memorized. You're either going to believe me and memorize them, or you are in for, it's going to be hard. You can't really do it without having that memorized. All right, so what are we doing? What are we going to do? What kind of problems are we going to do with those memorized things? Well, we are going to with no calculator, we are going to find the sine of 60 degrees. This is actually 4, 3, 4, 2, 4, 3 kind of combined All right, so let me double check that just to make sure I knew what I was talking about. I think I knew what I was talking about. No, this is actually 4-2. 4-2. All right, so here we go. We're going to find the exact sine of 60 degrees with no calculator. All right, so here's what I want you to do. First thing I want you to do is draw 60 degrees. All right, now we have spent some time talking about that. Is the ship sailing 60 degrees? No, this is in standard position, a 60-degree angle. So I start here. It's positive. 60 degrees would take me to about right here. Would you agree with that? That that's about a 60-degree angle in standard position. Now, once you get your angle drawn, I want you to drop a perpendicular to the x-axis. Now, the perpendicular that you draw, no matter which quadrant you're in, because obviously we can have angles in different quadrants, right? They're not all going to be in quadrant 1. No matter what you draw, the perpendicular has to come to the x-axis. So I call this the butterfly bow tie. Every triangle you draw will be a piece of the butterfly bow tie. So I happen to have quadrant 1 here. There it is. That's a 60. That's a 90. Oh my gosh, what's that? A 30. So now I can label the sides of that triangle. It's a 30, 60, 90. And I have memorized that across from the 30 is 1. Across from the 60 is root 3. And the hypotenuse is 2. I'm not making those up. They're never going to change. You'll memorize them. Those are the ratios of the sides in a 30, 60, 90 triangle. Okay, now wait. I want the sine. What sine? SOHCAHTOA. Sine is opposite over hypotenuse. All right, let's take a look at the picture. This is the angle right here. The one at the origin is always the angle you look at. Which side is the opposite side? Root 3. Which side is the hypotenuse? 2. The answer to the question is root 3 over 2. That was pretty easy. If I have everything memorized, I'm supposed to have memorized. Let's try another one. What if we wanted the cosine of 135 degrees? All right, so here we go. Same steps. First thing we're going to draw. Okay, so where's 135 going to be? Somewhere in the second quadrant. And where you get it exactly is not going to be important. Everybody understands it's over here somewhere, right? This is 135 degrees. Remember, every quadrant is 90. Okay, now what's the second step? I draw that perpendicular because I got to make a triangle, right? So then I drop that perpendicular straight down. Now, this angle right here is the important one, gang. Notice that the 135 isn't even part of the triangle, right? And that happens. It's fine. It's not the important angle. The important angle is the one right here at the origin. That's the important angle right there. So I need to use my thinking cap here for a minute. How big is that angle going to be? 45 degrees. Now, how can we very easily know that's 45 degrees? Exactly. This is 180, isn't it? Every quadrant is 90. So this was 90, this is 180. So if we went 135 of it already, the remaining piece would be 180 minus 135, right? I just use my logic, common sense. Okay, so that's 45, which means this guy up here is also 45. Now I can label the sides of the triangle. Do not use these numbers. It's a different kind of triangle. What are the sides in a 45, 45, 90? Across from the 45s are 1s, and the hypotenuse is root 2. Miss Word, how am I supposed to remember that? I don't know. You just need to. Now, here's a tricky part. This one is negative. Now, why is that one negative? It's on the left. And remember, this is the x-axis, right? And if you're on this side of the origin, on the x-axis, you are negative. This is not negative because it's going up. If we had one going down, which will be our next example, then that one will be negative, right? But in this case, that's a negative, that's a positive. Something else to remember. This is the x-axis, this is the y-axis. These can be positive or negative depending on where you are. This is the hypotenuse, or if you think about this as a giant circle, it's the radius. That number will never be negative, ever, in any problem you do. No matter how hard they get, the radius will never be negative. The hypotenuse is always a positive number. X and Y can be negative, or will always be positive. The radius will always be positive. Okay? So let's answer the question. I want the cosine. What's the definition of cosine? Adjacent over hypotenuse. Adjacent is the side right next to the angle. Remember, this is the important angle here. It's so important it has its own name. It's called the reference angle. The reference angle. So -1 over root 2, which we'll rationalize and say negative root 2 over 2 is the cosine.
Where'd you get it? So you can't have it first,
Oh boy. Tangent 4 pi over 3. Okay, well, unless you want to do the problem in radians, you're going to have to change 4 pi over 3 into degrees. Well, luckily, we know how to do that, right? And in fact, we're going to have a quiz over it tomorrow. So we need to change 4 pi over 3 into radians. Now, you can do your shortcut if you want. What do I know about pi? Pi is 180. Divided by 3 would be 60. Times 4 would be 240. Now remember, you're not going to have a calculator. So I would suggest you do it in that order. You got pi, which is 180. Divided by 3 is 60. Times 4 is 240. So we're finding the tangent of 240 degrees. All right, so we do what we do. We draw it. So 240 in standard position. Remember, we are starting here. So 240, around we go. Stop about here? Where exactly you stop is not important, but we definitely need to be in quadrant 3. Would you agree with that?
Yes.
240 is in quadrant 3. Jack?
Is it ever not going to start on the standard position?
Nope. Not unless it's a directional problem where you got a ship sailing on a course. Otherwise, no. It's always going to start on the positive x-axis. All right. Alright, what do we do once we get it drawn? We drop our perpendicular, or in this case, raise our perpendicular to the x-axis. Remember, every triangle you draw is going to be part of the butterfly bow tie. If you want to set me off, draw a triangle like this or something. No. They always sit or hang from the x-axis. Now, this is the important angle. 240 cannot be put into a triangle. I mean, it's just too big. So the important angle is the one right here at the origin, inside the triangle at the origin. How big would that be?
60.
I'm hearing 60s and I'm hearing 30s, and only one of those is correct. It is 60. That is a 60-degree angle. Remember, I am interested in the angle inside the triangle. Now, some of you are thinking, well, this is 270, and you're right. And you're thinking, okay, I need 30 more degrees. If this is 240, I need 30 more degrees. But that would be this angle, right?
Oh, you're right.
That is not the one in the triangle. I need the angle in the triangle. And it is indeed 60. Which means this is 30. So now I can label the sides of my triangle. So across from the 30 is 1, across from the 60 is root 3, my hypotenuse is 2. Anything negative in that picture?
There's -1.
The 1 is definitely negative,
There's the root 3.
and the root 3 is negative. Will the 2 ever be negative?
No.
No. The hypotenuse is positive. X and Y can be negative. And in this case, they are both negative because you're sitting in quadrant 3. And what do you know about X and Y in quadrant 3? They're both negative. All right, so now I want tangent. What's the definition of tangent? Opposite over adjacent. So this is my problem, it's my angle. Opposite over adjacent would be root 3 over 1, they're both negative. That would come out to just be root 3.
Yeah.
Right? One more. Make it as hard as I can. Here we go. How about the secant of 11 pi over 6? Oh, no. Let me make it worse. Let me make it 13 pi over 6.
No calculator.
No calculator. You don't need one. Here we go. First thing, that's a radian measure. I'm really not comfortable yet in radians, so I'm going to change it to degrees. And I can do that pretty quickly. I know pi is 180, right? Pi is 180. So pi over 6 would be 30. And now I have to take 30 times 13, which is 390. What about 390? Okay, I'm going to draw it anyway, but I'm going to recognize that I'm going to go all the way around and a little bit more. So there's a picture of my angle. I'm going to drop my perpendicular. Remember, revolution is 360. So if I'm going 390, I'm going more than a revolution. And then I got to figure out my reference angle. I always have to know that angle. That's the key. How big will that little angle right there be? 30. And we know it's 30 because all the way around was 360, right? And we went 390, so we went 30 more, 30 extra. So this is the 1, this is the root 3, and this is the 2.
All positive.
All positive. Sitting in quadrant 1, everything is positive. Don't have to worry about any negatives. But now I need the secant. Secant is reciprocal of cosine. Secant is reciprocal of cosine. What's cosine? Adjacent over hypotenuse. So secant will be hypotenuse over adjacent, which will be what? Hypotenuse over adjacent. 2 over root 3, which we don't like. So it'd be 2 root 3 over 3. All right. Multiply top and bottom by root 3. Can't have a radical on the bottom. Okay. You have in your packet one of the things that is to be turned in on your homework sheet. It says something about, you may have a homework sheet here. It says special angle worksheet or something. Yes, here it is. It's right here. It's in your packet. It's page 2. And you could actually do that now, at least some of it. These are the problems we've been doing today.
It's in our big packet.
It's in the big packet. Yep, it's page 2 of the big packet. So there is no reason why you don't have 4-1 and maybe most of the special angle. There's a couple of tricky ones on there we'll get to. I need to always have this in there. Oh.
It's like one of those legit. I don't know, it's just they pop up on my nose. There's our good time. That's kind of, that's why.
All right, have a good day. Maggie, can you turn off that video?